Hello, chemistry students. Today we're going to learn to do mole conversions, and we're going to be changing moles of a substance to grams and then vice versa. In order to do this, we need to set up some proportions, but you also need to be proficient in calculating the molar mass, which is what we learned the class period before. So in order to do this, you need to have a calculator and you need to have your chem helper. And if you don't have your actual chem helper, then you should at least pull up the electronic one that I posted to our Canvas page. So if you need to, then go ahead and hit pause on this video so that you can go and grab your supplies. Okay, so the first thing that I wanted to do is talk about how to set up a proportion. And here's the thing about proportions that I think is really cool. You can flip them and then they're going to say the same thing. So for instance, let's calculate the molar mass of oxygen, which has a formula of O2. And if you look at your chem helper in the square for oxygen, you'll see that 1 mole of oxygen is 16 grams, but we have 2 oxygens here, so we have to multiply 16 times 2. And when we get that, we get 32 grams per mole. Now, like I taught you before, you can write it like this, 32 grams per mole, or what you can do is write it like a fraction. So we're going to write, it's going to mean exactly the same thing, it's just going to look a little bit different. So we get 32 grams over 1 mole, 32 grams per mole. And this is exactly the same as writing it like this. We could even say that 1 mole equals 32 grams. My point is that all of these notations mean exactly the same thing. Now you're probably wondering, well, how do I know which one I need to use in order to solve the problems? Well, it depends on what you're given in the problem, because we're going to let our information that the author gives us in each problem dictate how we set up each problem. Let me show you what I mean. Let's take a look at our very first problem that we have, and I'm on page 4 in the packet. You can see the little page 4 there. And our first question says, how much does 10 moles of silicon weigh in grams? Well, let's take a look at what we're given in the problem. We are given 10 moles, and we're also told what we're supposed to look for. We're looking for the weight in grams. This is what we don't know. This is what we're trying to solve for. So I'm going to set up my proportion, the first side of it, using what I'm given in my problem. So I'm going to put 10 moles over X grams. This is all of the information that I'm given right here in the problem. And look I just put 10 moles on top because that was the very first thing that I came across when I was reading the problem. So now to finish my proportion, I need to draw an equal sign, and then I'm going to draw my little fraction bar that I have here. Now notice that I have moles on top of my fraction bar here on the left, and I have grams on the bottom. Well, I'm going to do the same thing on the right. I'm going to write moles on top, and I'm going to put grams on the bottom. Now, what numbers do I put here? Well, I know that I am looking for some amount of silicon. And if I look at my periodic table, silicon is right here, right below carbon. And I know that 1 mole of silicon is 28.6 0.09 grams. So I'm going to put 1 mole here at the top, and I know that 1 mole of silicon is 28.09 grams. So now I've got my entire problem set up, and in order to solve it, I simply need to solve for x. So in order to do that, I need to cross multiply and divide. So I'm going to cross multiply here, 10 times 28.09. Now if you need to punch that in your calculator, go ahead and do so. But 28.09 times 10 is simply 280.9. And that's going to be equal to my second side that I have to cross multiply, 1 times x. So that's equal to just x, right? Because we don't need to write the 1 next to the x. So here we are. This is my answer. I've got x on one side and it's isolated. There's no number associated with it. And it's equal to 280.9. But you're not done. You have to tell me what your units are. What am I looking for in the problem? Right here. I'm looking for grams. So in my answer, I need to make sure to have my unit. And this is my final answer. What I'm saying then is that 10 moles of silicon weighs 280.9 grams of silicon. So that's how I would solve problem number 1. Now let's take a look at problem number 2. Problem number 2 says, how much does 3.4 moles of water weigh in grams? Well, I'm going to do the same thing. In my problem, I'm given 3.4 moles, and I'm trying to find out how many grams that is. So let's set up the proportion just like I did before. Since, as I read my problem, 3.4 moles is the first portion, like the first given that I come to, then I'm going to write 3.4 moles on top of my fraction. And I'm going to put what I'm looking for in the problem below it, which is x grams. Awesome. Now I have to make that equal to another fraction. Since I have moles on top on the left, I keep moles on top on the right. And since I have grams on the bottom on the left, I'm going to have grams on the bottom on the right. Now I have to figure out what to put here. Well, first I have to go back to my problem and see what compound or what substance am I working with here. And in this problem, I'm working with water. Well, we all know already that water has the chemical formula of H2O. In order to put anything into this fraction, I first need to find the molar mass of water. Well, if we look at our periodic table, I have 2 hydrogens, which means I have to multiply 2 times the molar mass of hydrogen, which is 1.01, and I need to add that to 16, which is my molar mass for oxygen, and I've only got 1 oxygen, so I'm just going to put that there for 16. Well, 2 times 1.01 is 2.02, and when I add that to 16, I get 18.02 grams. And since this is the molar mass, I know that this is equal to 1 mole. So now I'm going to just plug in my 2 numbers over here on this side. So, whoops, sorry. Those are my stickers. So, let me get my right color pen here. So, even though, like, after I calculated the molar mass, I have grams over moles, it doesn't matter. I just have to make sure that my 18.02 goes by the G for grams in my proportion. And I have to make sure that my 1 next to the mole goes next to my abbreviation for mole in my proportion. Now I solve exactly the same way as I did in my problem above. I'm going to cross multiply and divide. So 1 times x is x, and that is going to equal 3.4 times 18.02. And when I multiply those out, I get 61.3 grams. And so that's how much 3.4 moles of water would weigh. Now, when you multiply 3.4 times 18.02, in your calculator, you should actually get 61.268. But you'll notice that I rounded my number to the nearest tenth. The reason for that is in my problem, the number that I have only goes to the tenths place. And so I'm going to keep my answer to reflect the number of decimal places that I have in my least precise measurement. Even though I used 18.02, by going out to the hundredths place, this number is more precise, but I want to keep my answer in tune with the number that is the least precise. So just count the number of places after the decimal, and your answer should have the same number of places after the decimal as the one that has the least amount, and then you'll be safe. Okay, so that's how we do our second problem. All right, let's do one more example where I've given you moles and I'm changing it to grams. So in problem number 3, how much does 0.3 moles of carbon dioxide weigh in grams? Well, once again, I'm given moles, so I'm going to write that down first. I get 5.3 moles. And I want to know how many grams that is. How much does 5.3 moles of carbon dioxide weigh? And now I'm going to create my other fraction. Since I have moles on top on the left, I'm going to keep moles on top on the right, put my grams at the bottom. And then, sorry, my lamp seems to have fallen. There we go. And then what I need to do is calculate the molar mass of carbon dioxide so that I know what numbers I need to put here on the right-hand side. Well, carbon dioxide has 1 carbon, so I have 12.01, and I need to add that to 2 oxygens, which is 2 times 16. That means I have to add 12.01 plus 32, and when I do that, I get 44.01 grams per mole. So again, I just need to make sure that my 44.01 gets inserted next to the G on my right-hand fraction here. So I'm going to write 44.01, and that's equal to 1 mole. Awesome. Now what I need to do is cross-multiply and divide if necessary. And so here, I just wanted to check something here. Yep. So here I have 1 times x is x, and x is equal to 5.3 times 44.01, and when I multiply that out, I should get an answer of 233.3, and I know I'm looking for grams because that's the unit that's next to my variable.